All right, in this video, I'm going to walk you through 3 examples that prove that trinomial factoring is not as hard as you think. And I'm going to do that using a strategy that I've been teaching for years on YouTube, and thousands of my students will tell you is a complete game changer when it comes to trinomial factoring. It's designed to make factoring fast, simple, and sidestep a lot of the confusing stuff that really makes factoring difficult. So you can see that I'm working with a trinomial with an a value that is not 1. That's your first sign that you can use the strategy I'm going to show you here. Most trinomial factoring strategies start by looking at the value of b, which in this case is 11. And we have to find 2 numbers that are going to add to give us that b value. But we also need those 2 numbers to multiply to give us whatever the product of a and c is. And in this case, that's going to be 24, right? 2 times 12 is 24. So 2 numbers that multiply to get 24 while also adding to get 11. Now, I think this is the part that a lot of students find challenging with factoring, is coming up with those 2 numbers. And I'm going to show you the strategy that I use to find those 2 numbers that I think makes things a lot simpler. I always start with the multiplication. So 2 numbers that multiply to get 24. There's a lot of factors of 24. You know, we have 6 and 4, we have 12 and 2. Now you can test any combination of those numbers, right? 6 times 4 is going to be 24, but 6 and 4 will not add to get 11. And this is sort of what I do, is I just kind of test out all the factors of 24 and see if I can come up with one that also adds to get 11. You're going to see that those pairs of numbers do not work. And if you repeat that process, eventually you're going to land on 8 and 3. Okay, so 8 times 3 I know is 24, and 8 plus 3 is also going to equal 11. Okay, so I've found my 2 numbers that satisfy my 2 conditions, 8 and 3. Okay, so this is where the crazy, insane strategy starts, and you're going to see things kind of looking random and weird. But the first random, weird thing we're going to do is write the 2 numbers that we just picked, which were 8 and 3, and we're just going to write them anywhere on our page. I like to write them underneath the trinomial just to keep things organized. You're going to write those 2 numbers, and you're just going to kind of randomly divide by the value of a, which you'll remember is 2. Okay, so we're going to take those numbers, divide them by 2. All right, so I just created 2 fractions, which is going to scare you, but I promise it's going to turn out okay. We're going to take these fractions and we're going to reduce them to lowest terms. Okay, so 8 over 2, that's just the same as 4 over 1. And it's important that I keep that 1. You'll see why in a moment. And 3 over 2 is already reduced. Okay, so I've got 2 reduced fractions. Now this next step is why I like to call this strategy the roundhouse kick strategy. Some people call it the tip over strategy. What you're going to do is roundhouse kick or tip over the fraction from left to right. Okay, so the numerator is going to fall next to the denominator. And I'm going to show you what that looks like with this first fraction. So our 1 is going to stay where it is. That's our denominator. And our numerator of 4 is going to land next to the 1. Okay, I'm going to put a positive here because it's a positive 4, and that's important, and I'll show you why in just a moment. Now I'm going to repeat that process with the second fraction, roundhouse kicking from left to right. I'm going to leave my denominator of 2, and I'm going to tip that positive 3 next to the 2. Okay, so I've just created 2 random pairs of numbers. This literally looks like total nonsense to anyone who's doing this, but it's this final step that makes things really come together. And that final step is just putting brackets around each pair of numbers and putting an X next to the first number in each set of brackets. And doing that is going to create the factored form expression for that trinomial. And if you don't believe me, you can take each term inside the brackets and then multiply each of them together, which I've just done for you to save you some time. And you're going to see that when I expand and simplify those 2 binomials, I end up with the original trinomial again. And this is going to work every single time. Even for this trinomial, you might be thinking, even for this trinomial. Now, before we get into factoring this trinomial, do me a favor and trinomial factor that like button if you're enjoying this strategy so that other people can discover it as well. Now, for this next example, you're going to see that the value of a, again, is not 1. We're dealing with a 3 here. So that's going to tell us that we can apply this strategy. But remember, like any trinomial factoring process, we're going to start by looking for 2 numbers that add to get that b value of negative 14, while also multiplying to get a times c. In this case, that's going to be negative 15. Okay, so those are the 2 conditions that we need to satisfy with our 2 numbers. Now this one's a little bit trickier because I'm dealing with some negatives here, but the process is going to be the same. We're going to start by looking for 2 numbers that multiply to get 15. You can try a pair of numbers like 5 and 3, but no matter what you do to 5 and 3, there's going to be no way you can add to get negative 14. So we're going to throw those numbers in the garbage. And as it turns out, 15 doesn't really have a lot of factors. I know that 1 times 15 will give me 15. My goal is to get negative 15, so I'm going to have to make one of those numbers negative. Now what I do when I'm placing a negative is I like to look at the 2 numbers I'm working with, and I like to just kind of ask myself what would happen if I made one of them negative. So if I made the 1 negative, for example, that will get me negative 15. But when I go to add negative 1 plus 15, I'm going to get positive 14, and I want negative 14. So making the 1 negative is not going to work in this case. So I'm going to see what happens if I make the 15 negative. Okay, if I make the 15 negative, I'm still going to multiply to get negative 15. But when I go to add the two together, I've got 1 and I'm going to add negative 15, and that's going to give me negative 14. So the two numbers I'm going to work with in this strategy are going to be 1 and negative 15. Okay, now remember the next step is to just write them somewhere on your page. Okay, so I'm just going to write them right here. I've got 1 and I've got negative 15, and I'm going to divide them randomly by the value of a. And in this case, a is going to be equal to 3. So I'm going to take 1, I'm going to divide by 3, and I'm going to take negative 15, and I'm going to divide by 3, okay? The next step of this crazy strategy before roundhouse kicking is to reduce the fraction to lowest terms, right? 1 over 3 is already reduced to lowest terms. Negative 15 over 3 reduced to lowest terms would be negative 5, but I'm going to keep that 1 in the denominator. We need a denominator for this strategy, so we're going to keep it there. Now you charge up your mightiest roundhouse kick, and you roundhouse kick from left to right. You knock that numerator of 1 next to the denominator of 3. We're going to keep it as positive 1 because it's positive in the numerator. And we're going to do the same thing with the second fraction. Roundhouse kicking from left to right. Our 1 stays where it is, and our negative 5 tips over next to our denominator of 1. And we've got two random sets of numbers that are going to become less random sets of binomials when we place brackets around them and put an x next to the first number in each set of brackets. So we've got 3x plus 1 times x minus 5 as our product of binomials in factored form. And again, we can check our answer just by distributing, expanding, and simplifying. And you'll see that I went ahead and did that for you to save you some time, to show that when I do expand and simplify, I end up getting my original trinomial back again. And again, that is going to work every single time. Now, before we move on to this third example, you're probably noticing just how random and arbitrary this strategy is. And I always encourage students who choose to use the strategy to practice it. And to help you out with that, I've created a worksheet that I've linked in the description below that you can grab right now so that you can master this really bizarre strategy. All right, so getting into this last example, again, you're going to see that we're dealing with an a value that is not 1. That's going to tell us that we can use this strategy. And like most factoring strategies out there, we're going to start by looking for two numbers that are going to add to get our b term, which is negative 17. And we also want to multiply to get whatever a times c is in this case. And a times c in this case is going to be 5 times 6, also known as 30. So my two conditions here are that I need to multiply to get 30 while also adding to get negative 17. So after some practice, this part of the strategy is going to start getting easier. It's playing around with a few numbers here. I'm going to pick on 15 and 2 because I know that 15 and 2 will multiply to give me 30, but they won't necessarily add to get negative 17 yet, right? 15 plus 2 is 17, so I'm getting close, but I need negative 17. But this one's actually kind of simple because if I choose to only make one of those numbers negative, my product will no longer be positive 30, it will be negative 30. And the only way to get a positive number when you're multiplying negative numbers is if you're multiplying two negative numbers, right? So negative 15 times negative 2 will give me 30. And as it turns out, negative 15 plus negative 2 will also give me negative 17. So you're going to start getting comfortable with that process once you start practicing the strategy regularly. Now remember, once we pick those two numbers, we're going to write them somewhere on our page. I'm just going to put them over here, and we're going to randomly take those numbers and divide them by the value of a, which in this example is going to be 5. Now before you get your roundhouse kicks ready, you're going to reduce each fraction to lowest terms. So our first fraction we're going to say is just negative 3 over 1, and our second fraction is already written in lowest terms. So we've got negative 3 over 1 and negative 2 over 5. We're going to roundhouse kick from left to right. Our denominator is going to stay where it is, and that negative 3 in the numerator is going to fall next to it. And same thing for the second fraction. We're going to roundhouse kick from left to right. We leave our 5 where it is. That negative 2 is going to tumble next to it. And we're going to end up with our two random pairs of numbers that become two less random pairs of binomials once we put some brackets around them and we slap an x next to the first number in each set of brackets. So we end up with x minus 3 times 5x minus 2 as our factored form expression. And remember, you can check your answer just by taking each term inside the brackets and multiplying it out, expanding and simplifying to get, you guessed it, the original trinomial back again. And remember, this strategy is going to work every single time. You've got an a value that is not 1, you follow this process, and you will end up with the correct factored form expression. Be sure to grab that worksheet in the description below, and for some more practice, you're going to want to head over to this video right here, and I will see you there.